Welcome to my channel Biography Zone.
Contributions to Immunology and Antibacterial Research. Fleming's research in immunology deepened as he began conducting experiments on different bacteria and their interactions with the human immune system. Some of his most notable early contributions included 1. Studying white blood cells, he observed how leukocytes, white blood cells, attacked and consumed harmful bacteria, further supporting the theory of phagocytosis. 2. Antiseptic research. During this time, antiseptics were widely used to treat wounds, but Fleming found that many actually harmed the body's natural defenses. This would later influence his wartime research. 3. Antibacterial substances. He began exploring whether certain naturally occurring substances in the human body had antibacterial properties, a line of thinking that would eventually lead to the discovery of lysozyme and penicillin. Fleming's careful observation, patience, and innovative approach set him apart from many of his colleagues. His ability to notice small details that others overlooked would eventually lead to his greatest discovery. Military service and wartime research. With the outbreak of World War I in 1914, Fleming's research took on new urgency. He enlisted in the Royal Army Medical Corps and served as a captain, working in battlefield hospitals in France. His wartime experiences gave him a first-hand view of the horrors of infected wounds, which often proved more fatal than the injuries themselves. At the time, antiseptics such as carbolic acid and iodine were widely used to treat wounds, but Fleming observed that these treatments often did more harm than good. Antiseptics killed both harmful bacteria and the body's own protective cells, leading to severe infections in many soldiers. Fleming's wartime research challenged these widely accepted practices. He advocated for using sterile saline solutions instead of harsh antiseptics, arguing that they allowed the body's natural immune system to fight infections more effectively. His observations and reports were initially met with skepticism, but they later influenced changes in medical treatment for wound infections. During this period, Fleming also continued his bacteriological experiments, collecting samples from infected soldiers and studying how bacteria developed resistance to different treatments. These investigations played a crucial role in his later discovery of antibiotics. Return to Street. Mary's and the search for antibacterial agents. After the war, Fleming returned to Street, Mary's Hospital, and resumed his research in bacteriology and immunology. His wartime experiences had reinforced his belief that better treatments were needed for bacterial infections, and he became even more determined to find an effective antibacterial agent. He continued experimenting with natural antibacterial substances, leading to his 1921 discovery of lysozyme, an enzyme found in bodily fluids such as saliva, tears, and mucus. This discovery provided evidence that the human body had natural defenses against bacterial infections. Although lysozyme was not effective against the most harmful bacteria, it paved the way for his later discovery of penicillin. By the late 1920s, Fleming was regarded as a leading bacteriologist, but his most important contribution to medicine was yet to come. Fleming's medical studies and early career were characterized by intellectual curiosity, meticulous research, and groundbreaking discoveries. His education at St. Mary's Medical School, mentorship under Sir Alexander Fleming, and experiences during World War I shaped his scientific approach and prepared him for his historic discovery of penicillin. His early experiments in bacteriology, immunology, and natural antibacterial substances provided crucial insights that would later revolutionize medicine. His persistence in questioning established medical practices and his observational skills enabled him to see what others overlook, an approach that ultimately led to one of the most significant medical breakthroughs of the 20th century. By the time he discovered penicillin in 1928, he had already spent decades refining his expertise in bacteriology and antimicrobial research, making him uniquely prepared for the monumental discovery that would change the world. Military service and wartime research. The outbreak of World War I and Fleming's decision to serve. In 1914, when World War I erupted across Europe, Alexander Fleming was already an established researcher in bacteriology and immunology at St. Mary's Hospital Medical School in London. At 33 years old, he had spent nearly a decade working under the renowned Sir Alexander Fleming, whose research focused on immunology and vaccine development. As the war intensified, it became evident that medical professionals would be essential in treating wounded soldiers. Recognizing the dire need for bacteriologists and medical officers, Fleming enlisted in the Royal Army Medical Corps and was soon assigned the rank of captain. His deep knowledge of infections and immune responses made him an invaluable asset to the British Army Medical Services, where he was placed in battlefield hospitals in France. This decision would profoundly impact his career. The war exposed him to the brutal realities of combat medicine, where he witnessed firsthand the devastating effects of untreated infections, sepsis, and gangrene issues that would drive his research in the years to come.